Number 5, it says, judging from the graphs, which of the following figures shows functions that are continuous at x equals 2? So we talked about a continuous function in general, right? But now we're going to specify where we want the function to be continuous at. And they've given us 3 graphs. And so we've got to determine whether or not it's going to be continuous. Now look at this. There's 2 ways to look at this. One is the graph itself, right? So let's unpack this first one. I can tell you for sure that that's not going to be continuous at 2. Does anybody know why? I mean, clearly when you look at the graph, there appears to be a vertical asymptote, right? Right here at 2. Why? Why is it that x cannot equal 2? Huh? What happens when x equals 2? If I were to plug 2 into this function, the denominator would equal 0. Can we do that? No. No, we cannot. Remember Mr. Adams said the infinite discontinuities are going to occur when you have fractions that have x in the bottom, and those values for x will make the denominator equal 0. So this is not continuous at 2. Let's look at the next one. Now this next one, is this one continuous at 2? Yeah. No domain restrictions. You look at the graph, it clearly, well, y equals 0, but 0 is a number, so it's defined, right? So here it's a totally different scenario. If I plug in 2 for x here, I'm going to get 2 minus 2, which is 0, but 0 is a number. And it's in our y value is defined, so that's okay. So now let's go to the next one. Well, here it's pretty clear by looking at the graph, right? Here it's obvious that there's, well, what kind of discontinuity is that? We just looked at them. Removable, right? Now, here is a different scenario. It's a little different than the first one, but again, if I plug in 2 into the denominator, right, I'll get 0 in the denominator, and I can't have that. So in this situation, I have a straight line where x just can't equal 2. So that's a removable discontinuity. And it's very obvious in the graph too, by the way that we graphed it, that it's not continuous. It's not a smooth curve. Okay? That's pretty much it.